Hi, so in this video, I'm going to show you how to model motion in 2 dimensions by considering the force and an acceleration as vectors. So if we look at example 1, we've been asked to calculate the acceleration in vector form acting on an object if the resultant force is 6I plus 8J and the mass is 6 kilograms. So we'll begin by sketching an object. And on this object, we have a resultant force of 6I plus 8J. So a force acting in roughly this direction. We'll call this F1, and we'll label it in column vector form of 6 and 8. So when this force acts on this object, it will cause the object to accelerate in the same direction. So it will accelerate in this direction. And we'll call this A. And to represent A, we'll give it a double arrow. Now, this force is a vector that it has magnitude and direction. The same is true for the acceleration. It has a magnitude, which is its acceleration, meters per second squared, but it also has a direction. So we can use the formula F equals ma to calculate this acceleration. The force in vector form is 6, 8. So 6 in the I, 8 in the J. And this is equal to the mass, which we're told is 6 kilograms. And this is a scalar because it has a magnitude but no direction. So the mass times the acceleration, which has x in the I direction and y in the j direction. So to work out x and y, we need to multiply both sides of this by 1/6. And this 6 and this 1/6 will cancel. So we'll find that xy is 1/6 of 6, so 1 in the I direction, and 1/6 of 8, so 4/3 in the j direction. And in vector form, we can say we have I plus 4/3 j meters per second squared. It's important that we include the unit, and this is the acceleration. Okay? So do you want to try with question B, where the forces acting on the object are 2, -3 for force 1, and -4 and 1 for force 2, and the mass is 8 kilograms for the object. So you can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you're ready to go. So I've drawn a quick sketch of a diagram. We have force 1 and force 2. So to work out the resultant force, which will be Fr, we can add these two forces together. So this will give us 2 and -3 plus -4 and 1. When we add these two together, we've got the 2, take away the 4 in the I direction, so -2, and -3 plus the 1 in the j direction, so again, -2. So we've got a force acting in this direction, Fr, on the particle. So the particle will accelerate in this direction as well. So we can say that F, the force, is ma. We've worked this out as -2 and -2. The mass we're told is 8 kilograms. And the acceleration will have an x and a y. So to work out x and y, we can multiply both sides by 1/8. So we'll have -2 times an eighth, which is -1/4. And the same for the j direction. So this will be the acceleration in meters per second squared. Okay? Let's try example 2. Okay, so in example 2, we're told that a particle is acted upon by a force of -4I and 3J, resulting in an acceleration of magnitude 4 meters per second squared. And we've been asked to work out the mass of a particle. So we'll sketch our diagram. We have our particle, and the force is acting in a direction of negative 4i plus 3j. So we'll label this as negative 4 and 3 in column vector form. We'll label it Fr. And this is causing the particle to accelerate in this direction. And the mass of a particle is m. And the magnitude of the acceleration is 4 meters per second squared. So because we have to work out the mass, and the mass is a scalar, we need to convert this force vector into its magnitude. So we need to work out the magnitude of this force vector, which we can do using Pythagoras' theorem. We know it's got 4 in the I and 3 in the j. So we can use Pythagoras' theorem to work out the magnitude. That would be 4 squared plus 3 squared. So a square root of 25, which will give us 5 newtons. So this is 5 newtons. So now we can use the formula. Force equals ma. So 5 will equal the mass times the acceleration of 4. So the mass will equal 5 over 4, or 1.25 kilograms. Okay? Let's move on to question 3. So for example 3, we're being told that we have two forces, F1 and F2, acting on a particle of mass 3 kilogram, giving it an acceleration of 4 in the I and 4 in the j, meters per second squared. And we've been given that F1 is 5 in the I, negative 2 in the j, we've been asked to work out F2. So again, I'm going to draw a diagram. We know we have F1 acting in this direction, so 5 across and 2 down, so something like this. This will be F1, 5 minus 2. There will be a second force that causes it to accelerate in the 4 direction, so something like this direction. And this will be the acceleration. And the mass of a particle is 3 kilograms. So we know that the resultant force must act in this direction, because that's what's causing it to accelerate in this direction. But we need to work out where F2 is. But we know Fr is equal to the mass of 3 times the acceleration of 4 and 4. So Fr must be equal to 12 in the I and 12 in the j. We also know that Fr is the sum of the two forces. So 12 and 12 must be equal to 5 and negative 2 plus F2, which we can say is x and y. So x and y will be 12 and 12 take away 5 and minus 2. So x and y will be 12 take away 5, which is 7, and 12 take away negative 2, which is 14. So this will be F2, and that will be in newtons. Okay? Let's try one more question. Okay, so finally, in example 4, we have a particle of mass m, and it is acted upon by 3 forces, 4i plus 5j, 2i minus 3j, and minus 6i plus 4j. And these 3 forces cause it to accelerate at a rate of 8 meters per second squared. And we've been asked to work out the mass of a particle. So rather than drawing a diagram, we can just say that the resultant force will be the sum of the 3 forces. So we'll use these in column vector form. So 4, 5 plus 2 minus 3 plus negative 6 and 4. We'll add up the I components. So 4 add for 2, take away 6, which gives us 0 in the I. And for the j, 5 take away 3, add 4, which gives us 6 in the j. And this is in newtons. But because we've been asked to work out the mass, and the mass is a scalar, we can see that F equals ma. we need to work out the magnitude of this force, because we've also been given the magnitude of the acceleration. So because Fr is acting vertically downwards by 6, its magnitude is 6. So 6 will equal the mass multiplied by the acceleration of 8. So the mass will be 6/8, which gives us 3/4 of a kilogram. Okay? So thank you very much for watching. I hope you found it useful. You can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.